Guys, are you able to hear me?
Yes, sir.
Yes, sir.
Okay. How many of them are there today? Bhagavat, Akash, Harshvardhan, Shreyan, Amrita, Kanishk, Harini. Guys, are you able to see me?
Yes, sir.
So what should I do today? I'll show you. See, the scenario is
Oh, only two guys. Sir.
yeah. So most of them messaged me saying that they have some exam. So what should I do? I can't even start a new topic. You want me to revise any previous topics? Any doubts that are there for your exam at least? At least now we can speak, no? Akash, Amrita, Bhagavat, Harini. Do you have anything that you want me to discuss? So I cannot start a new topic. I completed alternating current. Alternate AC
Yes,
is
sir.
over. Eddy current also have completed.
Eddy currents also over.
Okay, then I don't know. I'm supposed to start electromagnetic waves. But if I start others, I'll try. So what shall we do? You guys tell me. Any topics that you want me to discuss? We'll utilize it for revision at least. No doubt, sir. When is your physics? When is your physics? Tomorrow? Another one. Everybody is silent. At least today, less number of people are there. Online. The strength is more on online side. What do I do? You guys should speak. Amrita, there?
Yes, sir.
So you tell me, you have any doubts, any topics that you want me to discuss? Nothing? Harini? Any doubts, ma? Any topics you want me to explain? Harshvardhan, what about you?
I guess we can discuss the test paper. Asked about the test or paper answer I will discuss.
And then
magnetism doesn't one.
Moving charges and magnetism. Okay, we'll discuss that then. You have it for exam, huh?
Sir, exam முடிஞ்சிச்சு sir CV ல 5 6 7 sir.
5 6 7. Okay.
August 13th.
Adan finished the current electricity தான் போன class discuss பண்ணிட்டேன். Okay, we'll discuss that paper today. Actually, I can be quick. So if you see this question, the first one, So there is a uniform field that acts at right angles to the direction of motion of electrons. So wherever you see a magnetic field and direction of charged particles to be perpendicular, what is the path in which the charged particle travels?
Circular.
It travels in a uniform circular motion, right? Right angles and charged particle, right angles to the magnetic field and electrons means you can say it revolves in a circular path. Okay. As a result, the electron moves in a circular path of radius 2 centimeters. So R is equal to 2 centimeters. Suppose the speed of the electrons is doubled, then what will happen to the radius of the path? So I've given the expression. See, R is equal to, I want everybody to write this down. This is a formula where R is equal to mv divided by qb. R is what? Radius of the circular path is equal to mass of the particle into V divided by Q into B. Right. But what is mass into velocity? Linear momentum. So how will you write linear momentum in terms of kinetic energy? So what is linear momentum in terms of kinetic energy, guys? P is equal to root of 2m into K. You know this, right? Here. So K is equal to half mv square. P is equal to what? mv. So what I will do is, I'll multiply and divide with m. So what will happen to kinetic energy? It will become m square v square divided by 2m. But m square v square, now what is it? Is it not p square?
P square.
So p square divided by 2m is equal to k. So p square is equal to 2m into k. P will be root of 2m into k. This is a very, very important expression. Remember this. Right? So what I'm trying to tell you here is, radius can either be written as mv divided by qb, or it can be written as linear momentum divided by qb, or it can be written as root of 2m into k divided by qb, or it can also be written as root of 2m into ev is there, no? Ev is actually the energy of the particle, the potential energy of the particle. Internal charge, V is the potential difference. Okay. So when they ask you a question in magnetism based on radius, these are all the four formulas that you can use, especially the first three. Seriya? So from this I can conclude, since you are not changing the particle, I can conclude that the radius is directly proportional to velocity. So when radius is directly proportional to velocity, if the speed is doubled, what will happen to the radius? Answer is 4. So actually for this problem, we don't need this much of explanation. But I just got reminded of these formulas. I've seen problems based on them. Okay. So it becomes 4 centimeters. Second, so there is a rectangular coil ABCD which is rotated at a constant angular velocity about a horizontal axis as shown in the figure. The axis of rotation of the coil as well as the magnetic field are horizontal. The axis of rotation of the coil and the magnetic field are horizontal. Maximum current will flow in the circuit when the plane of the coil is perpendicular to the magnetic field, inclined at 30 degrees to the magnetic field, parallel to the magnetic field, inclined at 45 degrees to the magnetic field. And it is perpendicular what we have. When the plane of the coil is perpendicular, then the aerial vector will be the magnet. So here it depends on how much of torque you are able to generate. Okay. So the explanation is given here. See. So this is a concept that is based. Actually, there is a concept which is a combination of magnetic flux and magnetism. Because what did they ask? They asked maximum current will flow. Because in magnetic effects of current, we don't discuss about current. Okay, this question is actually based on Faraday's law of electromagnetic induction. So here you need to answer it in terms of flux. So if you observe, when you try to derive the expression for EMF, it becomes E naught sine omega t. Where did we get it from? From the concept of generator, right? So we can say that E will be maximum, then current is also maximum. When can they both be maximum? When omega t is max. So sine should be maximum. When is sine maximum? 90. So 90 is what? That is the angle between the areal vector and the magnetic field. The angle between the areal vector and the magnetic field. So if magnetic field is in a certain direction, then the coil is also supposed to be in the same plane for the areal vector to be perpendicular. So remember this, coil in the same plane also means areal vector is perpendicular. So that is why the answer to this question is it should be parallel to the magnetic field. That is the answer. Right? Third one. So A and B are two infinitely long parallel straight current carrying conductors. C is another straight conductor of length 1 meter kept parallel to both A and B as shown in the figure. That the force experienced by C is how much? So wherever you see infinitely long straight parallel conductors, right? The first thing that should come to your mind is the formula of force per unit length. So what is the formula for force per unit length? It is mu naught I1 I2 divided by 2 pi into d, where d is the distance of separation between both the conductors. Is that right? Right. So if I'm able to find the force per unit length, so what I'm going to do is C is another straight conductor of length 1 meter. So you need to calculate the force per unit length between A and C. So force per unit length between A and C is what you need to calculate first. Similarly, calculate the force between B and C. Right? So formula is F by L in Rika. Then force between AC will be equal to mu naught I1 I2 divided by 2 pi d into length of the conductor. So what is the length of conductor C? It is 1 meter. So since it is 1 meter, here you will substitute 1 meter. So mu naught by 2 pi d into I1 I2. Purida. So when you try to calculate it, you will get the value of force between A and C as 0.6 into 10 power minus 5. Okay. Yeah, I think it is 2.4. Minus 2.4 into 10 power minus 5, you will get. So why did I put a minus sign here is because, any idea why did I put a minus sign? Because in both the conductors, the current is in the same direction. If the current is in the same direction, will they repel or attract? It is exactly the opposite of what happens with charges. Like charges repel, unlike charges attract. Currents in same directions attract. So C will get attracted to A and C will get attracted to B also, because between C and B also, if you observe, currents are in the same direction. Okay. So if I take leftward side to be negative, force between AC I'll write it as minus 2.4 and force between BC I will write it as plus 3. When you subtract both, you will get the answer as 0.6 into 10 power minus 5 Newton. And that is the answer. Is that point clear? Right. Those who are online, are you clear?
Yes, sir.
right? So a student wants to increase the range of an ammeter from 1 milliampere to 5 milliampere. What should be done to the shunt resistance? So first of all, recollect. What is an ammeter basically? A galvanometer connected to a low resistance in parallel becomes an ammeter. Right? You have a galvanometer. If you connect a shunt resistance in parallel to the galvanometer, the whole thing becomes an ammeter. Right? So the ammeter's range is supposed to be increased. So if the ammeter's range is supposed to increase, what should happen to the overall resistance of it? It should decrease. So if it should decrease, recollect the point that when the current is to be measured by the galvanometer, the current is getting split as Ig and I minus Ig. Am I right? Right. So Ig is the current through the galvanometer. So every galvanometer, you're connecting the shunt resistance across the same galvanometer. So that galvanometer has a full scale deflection current. So only change you can do is with respect to the shunt resistance. So what should happen is if you want to measure more amount of current, that more amount of current which is flowing through the galvanometer should be ensured to flow through whom? Should it flow through the galvanometer or should it flow through the shunt resistance? Shunt resistance. If more current should flow through the shunt resistance, what should happen to its resistance value? Should you decrease it or increase it? The logic, what is fixed here? Ig is fixed. Correct. Doubt only. So the full scale deflection current of that particular galvanometer is fixed. I am measuring 1 milliampere initially. Out of that 1 milliampere, the fixed value of Ig is flowing through the galvanometer. The remaining will flow through the shunt. If I want to increase this 1 to 5, the same Ig value will flow through the galvanometer, but how much should flow through the shunt? 5 minus Ig should flow. Means more amount of current compared to the previous scenario is supposed to flow through it. If more current should flow through the shunt resistance, its resistance value should be decreased. So to put it in simple terms, what can you conclude? If you want to increase the range of an ammeter, what should you do to the shunt resistance? Decrease it. So answer is decrease. Since it's a 1 mark question, the keyword to expect is it should be reduced. Okay, that is for that reduced half mark. So I'll tell you how the board exam calculates. For reduce, the keyword is half mark. Reason reduce now to ensure that maximum current is going through the shunt resistance. For that half mark, both put together is 1. That is how it goes. Is it clear? So straight wire carries a current of 35 ampere. What is the magnitude of field at a distance of 20 centimeters from the wire? So due to a straight wire of infinite length, what is the magnetic field at distance r? Mu naught I divided by 2 pi r. That's the answer. So mu naught by 2 pi is how much? 2 into 10 power minus 7 into I is 35 divided by r is 20 into 10 power minus 2. So those many Tesla answer comes out to be 3.5 into 10 power minus 5 Tesla. Is that clear? See, this question paper is slightly tricky. I slightly gave you a tougher paper only. Concentrate discussing new concepts. If you observe, there is a 5 mega electron volt proton which is falling vertically downward through a region of magnetic field 1.5 Tesla, which is acting horizontally from south to north. Okay. Find the magnitude and direction of the magnetic field exerted, magnetic force exerted on the proton. Take the mass of the proton to be 1.6 into 10 power minus 27. Listen to this carefully. So first thing that they gave you is they didn't give you the speed of the particle. Rather, they gave you, what did they give you? 5 mega electron volt. What does mega electron volt stand for? It is a unit of what? Mega electron volt is a unit of A. Concept. What is mega electron volt? Mega is 10 power 6. Now, what is electron volt? Electron volt is the measure of whom? Chemistry la padichirukeenga, atomic structure la. When an electron jumps or transits between one orbit to another, minus 13.6 divided by n square படிச்சீங்களா? இது ஒரு ஞாபகம் இருக்கா? கஷ்டம். எது வெக்டர்? Did you guys see this kind of a formula, minus 13.6 divided by n square? 11th படிச்சீங்களா? Atomic structure படிச்சீங்களா? Or else you left it because it's deleted. இதுதான் சொல்றேன். சரி, what else can I give you? இப்போதைக்கு எழுதிக்கோங்க. 1 electron volt is 1.6 into 10 power minus 19 joule. 1 electron volt is 1.6 into 10 power minus. What is it? Work done. Now let's see. Work done. I'm asking what is the conversion. This 1 electron volt is this much value. So 1 mega electron volt will be equal to 1.6 into 10 power minus 13 joule. Okay. So why did they give you energy here is because if you read the question carefully, you have a magnetic field and they're expecting you to calculate the force experienced by the charged particle. When will a charged particle experience force in the magnetic field? When it is traveling with some speed at a non-zero angle. So if that should happen, you need to find what is the speed with which it is entering. Now, the formula F is equal to QEB. So you know the charge because it's a proton. You know the magnetic field, it is 1.5 Tesla, but what is missing? Speed is missing. So since I don't know the speed, what I will do is half mv square is the speed with which it is traveling, and that energy is equal to 5 mega electron volt. That is 5 into 10 power 6 into 1.6 into 10 power minus 19. Breathe. From this, what I can do is I can calculate V square. V square comes out to be 10 power 15. If V square is 10 power 15, V will be equal to 10 into 10 power 14. V square is equal to 10 into 10 power 14. V will be square root of 10 is 3.3. Square root of 10 power 14 is 10 power 7. Okay. So then what you need to do is you need to apply the formula F is equal to QVV sin theta. But here, if you look at the directions that they have given, they are indirectly telling you that the angle is 90 degrees. So here you will substitute 90, you know Q, you know V, you know D also. Substitute and find the answer, and the value comes out to be 7.58 into 10 power minus 12 Newton. Is that clear? Is that clear, guys?
Yes, sir. So, is it necessary to write that Flamingo's left-hand rule? Right?
You can even say, yeah, it's better you write it. It's better you write it. Yes.
How will you
Because
find
you will write magnetic force acts in eastward direction. Okay, but how? Using Fleming's left-hand rule. so that the person who's correcting will understand that you know this rule also.
Okay.
Okay. So as far as CBSE is concerned, if you give extra information also, there is no problem. Just underline it, whichever you feel is important. Fleming's left-hand rule important, underline it. Proton force acts in the eastward direction, underline eastward. Okay. So there is a 30 centimeter wire which is carrying a current of 10 ampere. It's placed inside a solenoid perpendicular to its axis. The field inside the solenoid is found to be 0.27 Tesla. What is the magnetic force on the wire? So the formula is F is equal to BIL sin theta. So B is 0.27, I is 10, L is 30 into 10 power minus 2 into what is sin theta? Sin 90 is 1. So when you calculate, answer comes out to be 0.81 Newton. Okay. Very fast. Okay. Eighth one. A long wire is bent in the given figure. Find the magnitude and direction of the field at the center O of the circular part. So when they say long wire, right? Long means infinite. Okay. So when it is bent in the form of a circle of radius capital R and current I is passed through it. If you observe, due to the straight current carrying conductor, the field at this point is how much? If I take the straight current carrying conductor to be 1, magnetic field due to the first straight current carrying conductor is mu naught I divided by 2 pi R. Right? What is the direction of it? Apply right hand thumb rule. It is this happened to go to confuse. Anti-clockwise will come about the induced current. You already current current now what is the magnetic field? Okay, right hand thumb. If you the current, okay, put your right hand thumb and find the direction of field. So at the bottom it is going into the plane. So in one of the directions it is into the plane, the other direction it will be out of the plane. Up out of the plane, the answer. So magnetic field due to the first current carrying conductor is out of the plane. Whereas due to the second current carrying conductor, that is a circular loop, what is the magnetic field at the center? The same current I is flowing, mu naught I by 2R. But what is the direction? Into the plane. So current is in clockwise direction. At the top, put your thumb in the rightward direction, curl your fingers. So it is going into the plane. So due to the circular current carrying conductor, it is into the plane, and due to the straight current carrying conductor, it is out of the plane. When you add them vectorially, they get subtracted. So I took positive, outward direction to be positive, inward to be negative. Adhanal da mu naught I by 2 pi R minus mu naught I by 2R. Those who are online, I hope you understood. Right? So there is a circular coil of 20 turns and radius 10 centimeter is placed in a uniform magnetic field of 0.1 Tesla normal to the plane of the coil. If the current in the coil is 5 ampere, what is the total torque on the coil? So torque is equal to NIPA sin theta. NIPA sin theta. So they use the word normal. So theta will be 90 degrees. So N is how much? 20. I is 1 minute. Wait. Normal need not be 90. See. So there is a circular coil of radius 20 centimeter, which is placed in a 10 centimeter placed in a uniform magnetic field, and the magnetic field is normal to the coil. So in the coil, this is the magnetic field. Magnetic field is normal to the coil. Then what is the angle between area vector and magnetic field? 0. So if it is 0, what will happen to the torque? Torque is M vector cross B vector. Another torque on the coil will be 0 here. Similarly, the total force on the coil by default is 0. Whenever you place a current carrying coil in external magnetic field, I repeat it again, current carrying coil is a magnetic dipole. Current carrying coil is a magnetic dipole. We discussed about two things: current carrying conductor and current carrying coil. What is a current carrying conductor? It is not closed. So current carrying conductor is not a magnetic dipole. Current carrying coil or a loop is a magnetic dipole. Whenever a magnetic dipole is placed in external magnetic field, it experiences only torque. So especially when you place it in uniform magnetic field. So it is exactly the same case as that of electric field. Electric dipole is placed in external electric field, uniform electric field. Net force is 0, but net torque is not 0. You will get it as P cross E. Adhe mari, magnetic field, you will get it as M cross B. So same logic. Whenever a magnetic dipole is placed in external magnetic field, net force is 0. So here also the net force is 0. So average force on each electron, you can leave it. That's not needed. So this one, I think I told on that day, right? You ignore 10B. So derive an expression for the frequency of revolution of charged particle in magnetic field and show that it is independent of velocity. So F is equal to QB divided by 2 pi M. It's very simple. R is equal to MB by QB. Time period is 2 pi R divided by V. So 2 pi into R is MB divided by QB divided by V. V and V get cancelled. T will be 2 pi M divided by QB. F will be equal to QB divided by 2 pi M. Hmm. 11th one. A current loop behaves as a magnetic dipole. Just now I told you. Right. Obtain an expression for the magnetic dipole moment of circular current loop. So instead of circular current loop, generally you can do it for a rectangular loop because that is the one that is there in your syllabus. Okay. State the rule used to find the direction of magnetic dipole moment. What rule do you use? Magnetic dipole moment. Right hand thumb rule. They are not confident. Right hand thumb rule. So you can either use right hand thumb rule or clock rule. You remember clock rule? When the current is flowing in clockwise direction, you will have north pole. Sorry, south pole. But how did you get that? Using the right hand thumb rule only. Is it clear? So when the current flows in the anti-clockwise direction, you will get north pole. So here they have given you some introduction about a solenoid. So basically, what is a solenoid? It is a long coil of wire which is tightly wound in a helical form and all those things. Okay. But if you look at the question, right, there is a long solenoid which has 800 turns per meter length of solenoid. A current of 1.6 ampere flows through it. The magnetic induction at the end of the solenoid on its axis. Remember, D is equal to mu naught into N into I. You remember this? But this is only at the center. So magnetic field at the ends will be magnetic field at the center divided by 2. So mu naught Ni divided by 2 is the answer. Okay. Make a note of this point. Right? So for that, the value comes out to be 8 into 10 power minus 4 Tesla. Okay. Choose a correct statement in the following. Let's see why each statement is wrong. So the magnetic field inside an ideal solid is not at all uniform. False. Because it is uniform. Inside what? Inside a ideal long solenoid. Second one, the magnetic field inside a solenoid is less than that of outside. Outside the solenoid there is no magnetic field at all. Third, the magnetic field at the center inside an ideal solenoid is almost the half of that at the ends. It is exactly the reverse. So what should be the right one? The magnetic field at the center is almost twice at the ends. So that is the right answer. Okay. Next, 14th one. The magnetic field inside a long solenoid having n turns per unit length and carrying current I when iron core is kept in it is how much? Mu is the permeability of vacuum and chi is the magnetic susceptibility. So B is equal to mu naught into N into I. But when you insert an iron rod, you can replace mu with mu into mu R. Because mu is equal to what? Or mu R is equal to what? Mu naught divided by mu. So mu naught is equal to mu into mu R into N into I. But mu R is how much? 1 minus chi. So mu into N. Oh, sorry, correct. I'm sorry, mu divided by mu. He's right. So this will become mu naught into mu. So it should be mu naught into N into I into 1 minus. Done. 15th. A solenoid of length L and having n turns carries a current I in the anti-clockwise direction. The magnetic field is. There is a solenoid of length L and having n turns carries a current I in the anti-clockwise direction. Magnetic field is somewhere inside the solenoid. Where is the magnetic field? Along the axis. That's it. That's the answer. So you cannot choose mu naught into n into I. Don't make that mistake, because mu naught into n into I is only applicable for the center part, not at the ends. So 16th one, the magnitude of the magnetic field inside a long solenoid is increased by. When you introduce a higher medium of permeability, what will happen is, you saw now what happens. It gets multiplied. So that's the answer. Okay. Next is seventeenth. Use Biot-Savart's law to derive an expression for the magnetic field due to a circular coil of radius r having n turns at a point on the axis at a distance v from the center. You already know the expression for it. B is equal to mu naught small I mu naught ni a square divided by 2 into a square plus x square power 3 by 2. Correct. Mu naught ni a square divided by 2 into a square plus, in the place of x here you will write it as b square. Okay. So you need to draw the magnetic field lines due to this coil. That is there in the textbook. You can have a look at it. It will be in this way. That is exactly from the 10th standard also. So this is an important question which I need to explain you. There is a current I that enters a uniform circular loop of radius r at point M and flows out of N. And flows out of N. Okay. Now obtain the net magnetic field at the center of the loop. So what is happening here is, see, there is a part of the current entering this side, right? It is not like it is going like this and coming out from this side. It is also going in the anti-clockwise direction as well. So what should happen is, at this point where I put an into mark, that is the junction where the current I is getting split into two parts. Right. So the current I gets split into two parts in such a way. This is I1 and this is I2, for instance. I1 plus I2 is how much? I. Is that right? So what happens in the case of I1? Now if you see, I1 is going through a smaller length. I2 is going through a larger length. So I1, or I can say I is equal to V by R. Can I say that? So current in a wire is inversely proportional to resistance. But how is resistance proportional to length? Directly proportional, provided the resistivity and area of cross section are constant. So I is inversely proportional to R. I can say I1 by I2 will be equal to R2 by R1. But instead of R2 and R1, can I write it as L2 by L1? Then R is directly proportional to length. So L2 evlo irukum? L2 is 3/4 of L and L1 is 1/4 of L. How did I decide it is 1/4 and 3/4? Because the angle says it. Angle is 90 degrees. Angle is 90, no? So how much is 90 degree? If I take a circle, this is 90 degree. What portion is this? Other than one day. Okay, the remaining is 3/4 of L. This and this will get cancelled. This will be 3. So I can say I1 is equal to 3 times I2. What did I say? I1 is equal to 3 times I2. Then I1 plus I2 is IDA. Up 4I2 is INA, I2 is I by 4. If I2 is I by 4, I1 will be 3I by 4. This is the only tricky part about this problem. So I2 is I by 4 and I1 is 3I by 4. Guys, those who are online, are you able to understand?
Yes,
Sir, I
sir.
understand.
Okay. So now, since you know I1 and I2, right? இப்ப பாருங்கடா. Observe, this is the most important thing. Well, the reason why I found I1 and I2 is because I1 is how much? Inga 3I, inga I current is. So sum of 3I by 4, I think, right? 3I by 4 and this is I by 4. Now, due to the small semicircular, small arc, what is going to be the magnetic field at the center? It is mu naught I divided by 4 pi r. Observe. Mu naught I divided by 4 pi r into pi by 2. If you revisit the concept of circular current carrying coil, right? I would have given you the formula for magnetic field due to a sector. Magnetic field due to a sector is mu naught I divided by 4 pi r into, you need to write the angle that the arc is subtending at the center. And the angle should be written in terms of radian. So this will be mu naught I divided by 8 pi r, but what is the direction? So what is the direction due to the first current carrying coil, B1 level? What is the direction? If you are correct, so Nitish, is it into the plane or out of the plane? Right hand, it is into the plane. Okay. What about B2? Mu naught I divided by 4 pi r. What is the angle subtended by the second current carrying coil at the center? In the angle, 3 pi by 2. So this will be 3 mu naught I divided by 8 pi r, which is in the direction out of the plane. And anti-clockwise current. So what are we supposed to do to these magnetic fields? When you add them vectorially, they get subtracted or added. So answer will be 2 mu naught I divided by 8 pi r, which is mu naught I divided by 4 pi r. And what is the direction? It is out of the plane. Right. So mu naught I divided by 4 pi r. Am I clear? Yes. This is no doubt a tough problem. But wait, I made a mistake. Made a mistake. Here, the current is not I. It is 3I by 4. I wrote it as mu naught I by 2 pi r. But the first conductor, what is the current flowing? 3I by 4. Dorkeda. So in the place of I should write it as 3I by 4. So that will be equal to 3 times mu naught I divided by 32 R. In the same way, what will happen here is in the same way, what will happen here is this is not I, correct? It is I by 4. Inge 4 multiply. So here there is a 4. So 32 pi R. So 3 mu naught I by 32 R and 3 mu naught I by 32 R are in exactly opposite directions, correct? So what will be the answer? So the net magnetic field produced at the center is 0. Okay. And the last question is based on galvanometer. I'm not reading the theory and all. We directly can write the answer. A moving coil galvanometer is an instrument which is used to measure EMF. No. Which is used to measure potential difference. No. Which is used to measure resistance. No. Measure water. No. Which is a deflection instrument which gives a deflection when current flows through the coil. Of what? You have gone to lab, meter which you use panning galvanometer. You didn't use meter which at all. The meter which panavai. Okay. At the time observe, it doesn't show direction. The balance point, what you do if you keep the jockey at one of the ends, deflection will be to the right, for example. Ade jockey, if you place it on the left of the meter, it will be in the leftward direction. That doesn't mean since you kept it to the left, it is to the left, and you kept it to the right, it is to the right. That depends on how you are connecting. A galvanometer also has a positive and negative. If you see, you have a red color knob and a black color knob. Another it is important. You can actually test and see. It doesn't show direction. Secondly, to make the field radial in a moving coil galvanometer, number of turns is kept small. No, it has nothing to do. You know what is radial field? Radial is perpendicular. Magnet is taken in the form of horseshoe. No. If you take it in the form of horseshoe, this end is open. You have nothing to do. Poles are of strong magnets. It has nothing to do with strength of the magnet. And the last one is poles are cylindrically cut, and that is right answer because they are in the shape of concave. When you see it from the top, cylindrical polar. I showed you an animation. Once you go and check the video, I will show you an animation. It is actually a cylindrical part, but when you see it from the top, it will appear like a circle. Okay, the deflection in the moving coil galvanometer is, we know that torque is equal to K theta. Torque is the restoring torque is equal to K into theta, where theta is the angle. Okay, so torque is equal to NIAB. So K theta will be equal to NI into AB. You remember this? From this only we derived the current sensitivity, figure of merit, voltage sensitivity and everything. So the reflection in a moving coil galvanometer is directly proportional. Theta is directly proportional to the number of turns. In a moving coil galvanometer having n number of turns or an area A and carrying current I is placed in radial field of strength B. The torque acting the coil is radial field abdinale perpendicular. So torque is NIAB sin theta. Theta is 90 degrees. So answer NIAB. Okay. To increase the current sensitivity of the galvanometer, current sensitivity is I by ampere per division is equal to, in the formula we will write it, K divided by N into A into B. So to increase the current sensitivity, increase the torsional constant. See, everything else is inversely proportional. Strength of the magnet inversely proportional. Number of turns inversely proportional. Area is inversely proportional. So torsional constant is directly proportional. So answer will be torsional constant of the spring. Is it clear? So this is all about paper. Guys, those who are online, are you clear?
Yes, sir.
Okay. So that's it, guys. So we'll wind up. I'll let you know about the tomorrow's about this week's class by tonight. Okay. So I'm just ending the session. We'll leave. When wind up, guys.